The basics of shallow foundations. Welcome back to Blueprint to Reality, where we break down the engineering behind the structures we live, work, and move through every day. Today, we're going underground, quite literally, as we explore one of the most essential yet often overlooked components of construction, shallow foundations. They're simple, cost-effective, and form the base of most buildings we see around us. But how do they actually work? Let's get into the fundamentals. What are shallow foundations? A shallow foundation is a type of building foundation that transfers structural loads to the soil at a relatively small depth, typically less than the width of the foundation itself. They are built close to the ground surface and are used when the soil near the top has enough strength to support the load of the structure. Unlike deep foundations that use piles or caissons to reach deeper soil layers, shallow foundations spread the load out horizontally over a large area. Think of them as the wide feet of a building that help distribute weight without digging too deep. Why use shallow foundations? Shallow foundations are used in a wide range of projects for a few good reasons. First, they're economical, less excavation, less material, and less labor. Second, they're simple to design and construct, especially in small to medium-sized projects like houses, small buildings, and light industrial structures. They're the go-to choice when the top layers of soil are strong enough to carry loads, and when there's no need to go deep into the ground due to groundwater, weak soils, or other issues. Types of shallow foundations. There are several types of shallow foundations, each serving a unique purpose based on the structure, soil, and load requirements. Spread footings. These are the most common. A concrete pad is placed under columns or walls, spreading the load across a wider area. Great for buildings with moderate weight. Strip footings. These are continuous footings beneath load-bearing walls. They form a long strip and support walls that run over a large length. Mat or raft foundations. Used when the building loads are heavy or the soil is weak. A large concrete slab covers most or all of the building footprint, distributing weight evenly. Combined footings. When two or more columns are close together, their footings may be combined into one slab to distribute loads efficiently. Each of these types is chosen depending on column arrangement, soil pressure, building loads, and project constraints. Soil interaction and bearing capacity. One of the most critical aspects of shallow foundation design is understanding soil behavior. The bearing capacity of the soil, its ability to support load without failing, is what defines the entire foundation design. If the soil is too soft or compressible, even a perfectly designed shallow foundation can settle unevenly or fail. Engineers conduct soil investigations, borehole tests, and standard penetration tests, SPT, to determine the safe bearing capacity. Once the soil properties are known, the foundation size is calculated to ensure that the pressure from the building is less than the soil's bearing capacity. The key is not just holding up the structure, but doing so safely and without excessive settlement. Construction process of shallow foundations. The process is fairly straightforward. Excavation is done to the required depth, usually between 1 to 3 meters, depending on the building. Formwork is installed for footings and reinforcement bars are placed to improve strength. Concrete is poured, cured, and compacted to remove air voids. Once the concrete has gained strength, the foundation is backfilled and compacted. In residential construction, the entire shallow foundation process can sometimes be completed in just a few days, making it extremely time-efficient. Advantages and limitations. Shallow foundations offer numerous advantages. A cost-effective for small to medium buildings. Fast construction with simple equipment. Easier inspection and repair, since most of it is near the surface. However, they do come with limitations. In areas with expansive clay soils, high water tables, or heavy structural loads, shallow foundations may not perform well. They're also more vulnerable to frost heave in cold climates, unless built below the frost line. That's why a proper geotechnical investigation is essential before choosing the type of foundation. Real-world applications. Shallow foundations are everywhere. Most houses, schools, and small commercial buildings use isolated or strip footings. Even some multi-story buildings in cities with dense, strong soil are safely built on raft foundations. For example, in downtown areas with dense sandy soils, Engineers often prefer raft foundations for mid-rise buildings to minimize differential settlement. In contrast, individual spread footings are common in suburban housing developments. Each solution is tailored to the site, and that's what makes foundation engineering so fascinating. It's a blend of science, soil, and structural logic. Conclusion: shallow foundations may be hidden beneath our feet, but they're the first and most critical step in building anything durable. From homes to hospitals, they quietly carry the weight of our everyday lives, making sure the rest of the structure stands tall and strong. As we continue to push the limits of construction and urban development, foundation design remains a core pillar of engineering, literally and figuratively. Thanks for joining us today on Blueprint to Reality. If you found this helpful, make sure to subscribe for more clear, engaging insights into the structures that shape our world.